screen and just a second. Okay, cool. So, all right. So I want to believe that everyone can see my screen, right?
Yes.
Oh, lovely. Okay, great. Thank you. So I'm just going to start a new application. I'm going to call this integrated integrated streamlit. I'm just change this to stlt dot py. All right. So I'm just going to start a new file from the scratch. Now, whenever you build a web application or you build a machine learning model or something, or anything you build, you want to share it with the world. So there are various ways you can share it. Now, you can deploy it as an application using Tkinter or Kiwi. Okay, so first you can deploy it as a desktop application. And when you deploy it as a desktop application, you would use one of this either Tkinter or PyQt or PyGUI or any of these GUI applications. And that's what you're going to use to deploy for your desktop consumption. But then sometimes you don't want to go the desktop route. You probably want to use it on an Android device or an iOS device or something. So when you want to do that, you have to deploy it using this Kiwi MD. All right. And we've touched a bit of all of this in our previous sessions. So, but today we want to look at what would happen if you want to deploy the app via the web. So we probably want to just send somebody a link to say, hey, check this thing out. You know, this is how this stuff works. So what we're going to do today is we're going to introduce how Streamlit works. Streamlit is like Python's #1 web applications framework. And we just want to introduce how it works. And once we find out how it works, the next thing we want to do is to try to deploy an ML application on it. All right. But what we're going to do right now is that for today, we're going to deploy it on a local host, which means I'm just going to run it off my desktop. Next week, hopefully, I'm just going to show you how to push what you've deployed to Git. All right, so use Git and then push it into GitHub. Then from GitHub, we host it on streamlit.io website. And then from there, you know, you just get it done. So let's just hit the road. I'm just going to close all of this. 1, 2, 3, 4, 5, 6, 7, and I'm going to leave that running. So for your web app, again, I'm just going to recap what I just said earlier. You need 3 things. You need a Streamlit account, that's streamlit.io, streamlit.io. Okay. Sorry, this is dots, not comma. Okay. So Streamlit, yes, streamlit.io. So you probably need this on streamlit.io. Then you need a GitHub account. So I'm just going to show mine, GitHub, hub.com. All right. I'm going to log into mine. Okay, but we really would not need this today. So we would need all of this next week when we push GitHub to, when we push our code via Git into Streamlit. All right. So but today let's just go into the nitty-gritty of Streamlit. Please remember, Rahul, MS, Ndita, you can just stop me at any time. And it's a live class. Don't worry about the recording. Yeah, the recording is there, but don't worry about spoiling the recording. hey, everyone is going to know it was a live class. So feel free to just ask questions. It's about you really, it's not about the recording. The recording is just for the benefit of those who probably could not make it, right? So it's just about you, and we just want to make sure you have fun and you can have, you can ask any questions that you have. And if you don't want us to,
sure.
If you want us to edit your question part away from the recording, we'll always be glad to do that. All right, so we just want you to have fun. That's just what it is.
Yeah, yes, sure.
Right, okay, so let's start. The first thing I'm going to do is I'm going to import Streamlit, all right? So import Streamlit as st. Okay, so when I do this, I have my Streamlit already. Now, okay, so I have my Streamlits. If you notice here, you'll notice that I use Anaconda Python distribution, and Anaconda makes me very lazy. So because practically everything I need for data science is already bundled inside of Anaconda, and I could always just, most of the libraries that we need for data science is bundled in there. So I really get to just log in and just check the distribution to just make sure the library is there, But if the library is not there, I could always run a pip install from this, this place. All right. I could run a pip install from here, or I could just kick up my command prompt. So that would be Anaconda prompt, because I use Anaconda. So once I just kick this up, I just run the conda install and the library, the command. So that's how easy it is, to get things done on conda. All right. So, but this is just in case you write this import Streamlit as st and your computer complains, all right, that maybe the stuff isn't installed. It's not something very strange, okay? So, so the next thing we're going to do is just to look at, last week I told you about documentations. I like documentations a lot. I like to read the documentation. And the reason I like to read the documentation is because it tells me what to expect in the library that I'm working with. So this is Streamlit's documentation. And one of the reasons why Streamlit is like everyone's favorite library is because it's straightforward. You're not making any HTML calls, you're not scripting anything, you're not doing anything. It's just straightforward. You're not trying to render any JSON or stuff like that. You just enjoy the straightforwardness of the app. And I'm going to show you how straightforward it is. Whenever you hear web application or any application at all, Android, iOS, or whatever, one of the things that always should come to your mind is widgets, because an application is made up of a user interface where you have widgets that allow you to do stuff. So you have a widget that takes in information. You have a widget that's like an action button. You have a widget that scrolls, scroll bars. You have widgets. So it's the same thing with Streamlit. Streamlit is just made up of plenty of widgets. All right. So we're just going to look at some of the widgets that make up Streamlit. All right. And elements basically that you can interact with in the course of building your app. So if you look at this document here, which is streamlit.io API reference, you can always find it online. I'm just going to copy this and put this in the chat area. So let me just put this in the chat area right now. Okay, so you have it in the chat right now. Yep. So if you look at this API reference, it's just straightforward. It just tells you how to achieve anything you want to achieve in Streamlit in your app. All right. So let me just start taking them one after the other. First, let me go to my Visual Studio. Okay, full disclosure, I like Visual Studio for Streamlit because It's one of the most interactive and most intuitive IDEs to use for Streamlit. When I'm building a machine learning solution, I like using the notebook, but when I'm working on Streamlit, Tkinter, Kiwi, or any of those frameworks, I like to use Visual Studio because you'll get to see it shortly. It's very intuitive. It helps you with the code, all right? And if you have Kites, which is an AI-assisted tool embedded inside of Visual Studio, you're good. You're good to go. Okay, so let's just start. Since we have imported Streamlit as ST, let's start. Let's just do ST dots. Now you see a lot of things that you could, use, but let's start with ST dots title. All right. So, and one of the things you notice about widgets, one of the things you notice about widgets in what do you call it now in Streamlit is that every widget expects you to have a text, all right, which is either described with this name body or whatever, but it's just usually a string, a piece of string that just displays. So it tells you about that string. So let me just use this, like, let me just put this word title, and I'll call this the integrated MLAI application. So this is like the title, all right? So if I run this right now, because this is the first line of code in my Streamlit application, this is what's going to happen. Okay, so let me just run this code right now. You would notice something is going to show up here, all right? And just a second. Okay, I think because my Visual Studio has been running, that's why it's not showing. But I want to just pretend that this is the first time I'm running my Streamlit. So I'm just going to restart my Visual Studio. And come on. Right, freeze. Okay, so yep, let me just restart my Visual Studio. And so that I'll just pretend that this is the first time I'm running Streamlit. So let's see how that plays out. Okay, so cool. Let me open up this. We had it as integrated. Yep, this one. Okay, so now I'm going to click on run here. Okay, cool. Yeah, I'm going to click on run Python file. So that, let me just drag this up a bit and move this to the top. Okay. So, cool. So it's running right now. You'll see some messages showing up shortly. I don't believe you can all see my screen, right? Please, if you can't see my screen, just let me know.
Your screen is visible, yes.
All right, great. Thank you, Aziz. So this is, just keep watching this, my terminal area, this place, because this is where the message is going to come up. All right, so now it's telling me now, because this is the first time I'm running my Streamlit app, I have to let it run in a browser. Streamlit is a web app, so it has to run in a browser. All right, but for it to run in a browser, I have to enter this command in my command line app. Yep, my command line. Now, I told you if I wanted to, I could just crank up my Anaconda command, Anaconda prompt here, which is this, and I would type in this command that it asked me to type in here. But why do I want to go through that stress where I can already see my command line here? This terminal you're seeing here as part of Visual Studio is actually your command line, all right? So I usually do not have need to go to an Anaconda prompt, open the command prompt and start typing. This terminal serves as my command line. So I'm just going to copy this thing it asked me to run. You can see the code it asked me to run is streamlit.run, and this is the path to the file where the Streamlit instruction is. So this is my Python file, and this is the path. So all that is asking me is to copy this and then run it in a command prompt, or I could run it here. So I just copy it and paste it back here, and then I'll press enter so that it can run. So now you can see it's running, and it's going to prompt me. It's going to show me something right now. Cool. So it's telling me now, yeah, you can now view your Streamlit app in your browser. So automatically it has finished configuring that stuff that it wanted to configure. And then it's telling me right now that when I click on this, yeah, it's going to open up in my default browser, which is Microsoft Edge. All right. So Microsoft Edge is my default browser, and yeah, it's opening up Streamlit. So you can see what we have here, integrated MLA application, which is the title. All right. So we're ready to roll. We're ready to roll. So now I can decide to say, okay, let's add another. You can see all of this here in this API reference. All right. So you can add a title, and you can see the code to write the title, st.title, because you have imported your Streamlit as st. So st.title, the title of the app. All right. So I could just put a header. Again, very simple code, st.header. This is header. So let me just put that here. So st.header. All right. And this is a header. Again, you can see all it just requires is the body, which is the title, all right, or the key text that that thing will show. And then if there's any anchor and all of that. So I'm just going to save this. That I'm going to press Ctrl S. Now, when I press Ctrl S and I go back to my browser, you will notice that, let me just close this so it doesn't distract us. You will notice that my browser, okay, let me just press Ctrl S again. This is the header, and I'm going to do Ctrl S. So you notice, come on. Okay, yeah. So you've noticed that this prompt shows up to say my source file has changed. What do I want to do? And I'm going to say I want to rerun. All right, so I'm just going to click on this rerun, and then it's going to re-render it again and add the latest line of code that I've added in this stuff. So I could decide to add one more line of code here. Let me just make it a subheader. Remember, you can see all these APIs, all those codes here. So this is a subheader. Again, st.subheader. Very simple. Okay, so I'm just going to write st.subheader. All right, and I put this is my subheader. Once I save it again, when I come to this place, you'd see the message again. Something has changed in the source file. So I'm going to rerun it. And then, yeah, you can see. So that's basically what Streamlit is. Streamlit cuts off the need for you to write HTML code and all of that. So you see a lot of options for you. You see a lot of widgets that allow you take in data. You also see a lot of widgets that allow you give out data. You see a lot of widgets that allow you charts, create charts and all that. We're going to look at all of these advanced widgets next week. But for this week, we're just going to take the easy way and just, so we have input widgets like buttons, for example. You can just st.button and you create a button. So let me just put that here. st.button. And all the button requires for now is what will show on it. So I could say, click me for dollars. All right. And once I save and I come here, it tells me something has changed again. So I run. And then here, that's my button, click me for dollars. So that's how easy it is. Though here, if you look at this button widget, you'll notice that if I put a comma here, you notice that there are some other parameters. And this is why I told you I love Visual Studio Code, because it tells me all the parameters that I need to supply or that this function or this widget would require, so that I really do not need to bug my head cramming all of them. So in this case, yeah, apart from the label, there could be a key, there could be, if I wanted to have a help button, if I wanted to add an instruction as on what should a command, what should the system do when I click on this button, I could add it. All right. So there are other things. Oh yeah, MS, go ahead.
First of all, thank you. This is, it's my first session, and you're a great teacher. It's just, it's my first time learning Streamlit, so it's going great.
Right.
So thank you.
Okay.
So my question is, I can see the difference between Flask and Streamlit, and it's pretty straightforward, easier to deploy. Deploy, I don't know, we will do that next time, but to create, is there any other, how would you compare Flask and Streamlit, number one, or are there any applications where you would just use Flask and not use Streamlit, or the otherwise?
Okay, that's one. You have another question?
No, just that.
Okay, just this. For me, I think, okay, so this is why many people still use Flask as against Streamlit. So if you go to streamlit.io, just move this down. Yes. Okay, so if you go to streamlit.io, you would notice that there are, let me just see. Okay, so you've noticed that, yeah, they have payment plans. So it's not like it's totally free. For example, like right now, I'm using the free community version, which entitles me to, yeah, I could have unlimited apps, all right? But then I could only have one private app and 3 people in my workspace. But for teams or for enterprise, it comes with a lot of other things. So for some people who think they don't want restrictions, they tend to say, okay, let's just deploy on Flask. But really, I think Streamlit, apart from the ease of deployment and everything, Streamlit is still like the better of the two, if you ask me, based on my user experience. So, because like for us Python users, one of the things we thrive on is simplicity. I personally find Ginger and all of that a bit more technical compared to how easy Streamlit is. So if you ask me, my first choice is Streamlit. Yeah, I can have unlimited apps that I can share with everybody, all right? But it's just a bit restrictive, unlike Flask where there are no limits really. Yeah, so that's it. But I think for now, I really do not need more than one private app, all right? I really do not need more than 3 people in my workspace for now, because I mean, it's just me. I'm just coding for myself and I'm deploying and sharing it to the public. So yeah, so as long as I can share my apps with everyone, I'm fine. That's what I think.
Thank you.
Yeah.
That makes sense.
Right. Okay, so let's go back to this. So that's what you get to see with this widgets like the button, which is a bit more advanced. But like I said, if you use a very good IDE like Visual Studio Code, it's going to help you, just get all of that dealt with. So maybe we should just take 1 or 2 more APIs. See, okay, checkbox, all right. A radio button. Okay, let's just take 1 or 2 more. Let's take a checkbox. All right, so let's create a checkbox, st.checkbox, and it requires a label, and it requires the values, all right? So, let's take the first, which is the label. Let's say, what is your favorite food, all right? Then the next thing I would do is to supply the keys. But if you look at it, you'll see the key requires strings, all right? And value requires Boolean, all right? So let me just put this. Let me put the strings in a list, and then let's see how it turns out, right? So let me use, what's your favorite food? Let me say rice, and let me put chicken here, and then let's see how that pans out. Okay, so let me run this. So what's my favorite food? Okay, so yeah, this checkbox is just to, you know what a checkbox is? It's just to take an input, yes or no. Yes or no. All right, so my bad. I was mistaking that for, so let me just take this away. Okay, so checkboxes are just to take inputs like, okay, I agree to the terms and conditions, to the terms and conditions. All right, yeah, so that's what the checkbox is. Yeah, so that's it. Then the other one I was confusing it was like a select box. So let me just put that as an example here. st.selectbox, and yep. So this one needs a label, which is, what is your best meal? All right. Then the options, let me see. Let me see. Okay, so let me put a list here, and let's see, rice and chicken. Okay, then let's rerun this. Okay, so this is it. I get to select anyone, and then, so that's just basically how the stuff runs. It's just intuitive. You just keep feeling and just, you know, whatever it is you want. So I'm just going to delete all of this so that we can go straight to business. Right. So let's say I want to build an application, all right, for integrated ML/AI. Maybe later I'm also going to show you how Streamlit interacts with audio, videos, and images. All right, but let me just show you how it interacts with images. Okay, so I'm going to import this library image from this class called PIL, this class library called PIL, or module if you like. So I'm going to import image, all right? And what I'm going to do right now is I'm going to create, for those of you who were there when we were treating object-oriented programming, you would notice that the first thing I do whenever I import all of this is to create an instance. So image.open, all right? So I want to open this image, and again, my ID is going to tell me everything about, you know, that I need, every parameter I need to supply. So the first parameter I need to supply is either a string, bytes, a path, or, read bytes. So I'm going to supply a path, and I'm just going to take this image. This is the image I want to use. It's on my desktop. So if I want to copy the path of the image, I'm just going to hold the shift button, and right click the image. When I do that, you would see that this option of copy as path comes up. But if I just right click on it, that option doesn't show up. You want to see it. All right, but the moment I hold the shift button and I right click on it, you'll see the option to copy it as path. So I'm just going to copy the path, and I'm just going to come and paste it in here. Right now, sometimes your system might reject it if you just paste it like this. Sometimes it might accept it, but in order to be safe, there are some formatting strings that we normally like to add. So I like to add this R, which converts this to a raw string. Why? Because sometimes when your system is reading this backward slashes, it tends to see them as escape instructions. You have a backward slash with an N to tell it to go to the next line, a backward slash with stuff like that. So if you don't convert this to a raw string by just adding this R in front of the text, your system might be tempted to think of it as an escape instruction. All right, so that's why I always add the R there, just like a buffer. It just prevents any of those things from happening. All right, so since we have imported the image using this image library, what I'm going to do right now is I'm going to now use this st.image, which is Streamlit's image handler. And when I open it, you see the first thing it's asking me for is an image that I want it to bring in. And then if I want it to display a caption, stuff like that, if I want to change the width and stuff like that, but I don't want to change the width. So I think I'm okay with it. So I'm just going to bring in the image, and I'm going to use this name img because that's what I created my images. I instantiated the image class using the variable name img. So let me run this right now. Go to my app. Okay, so the source file has changed. Rerun, and here we are. So that's the image. All right, it just pops the image up. So this is what I want to show at the top of my app. Then the next thing I want to do is to add a title. So I'm just going to do st.title, and I'm going to open the brackets, and I'm going to call that integrated ML AI app. Okay, again, I'm going to run this, and yeah, we're good. So now, what I want to do right now is I want to try to deploy a machine learning application. Okay, so but then before I can deploy a machine learning application, I have to have a data set, train the model, and after I train the model, then I will, test the model, then deploy the model through the app. So this is the data set that I'm working with. It's a very small data set, because I needed to not waste our time training. So just a small data set. It's a data set of the amount of expenses spent on a company's TV advertisements, radio ads, and newspaper ads. So this sales is the target, all right? It's a target variable. So basically what the data set is saying is this: we spent 66.1 thousand on TV, we spent 5.8 on radio, and then we spent 24.2 on newspapers. So we use this spending to try to predict what the sales will be like. That's basically what this is. Same for this, 97.5 on TV, this on radio, this on newspapers, we got 9.7. So this is obviously a regression problem. And what I've done is I have done this. I'm going to share all of this with you as soon as this class ends. So what I've done is I have tried to do the training of this with scikit-learn. Again, so I believe that this is something you'll be conversant with, or if you're not conversant with it, we'll talk about this some other time later. So, but I just imported pandas, imported my train test splits and stuff like that. And I used pandas to read the file. So I displayed the first 5 rows in the file, which shows me this. Then I tried to visualize the variable. So I visualized the first variable, which is TV against sales. This one is radio against sales. And then this one, this third one here, is newspaper against sales. Now, from the first one that I see here, yep, newspaper, TV against sales, there's some form of correlation. At least you could see the stuff is not very bad. For radio against sales, you could also see some form of correlation. But for newspaper against sales, you can see it's useless. It's not useful to us. It's just noise, all right? But I did not drop it. I just had everything in there like that. So that's how I just created my XY. So I don't want to bug you with all these details. I did my train test, you know, invoked and instantiated this linear regression class, where I did my fits, did my predict. Now I got my metrics. And since this is a regression problem, we don't talk about the confusion metrics. We just talk about things like the loss function, which is the mean squared error, and then the R squared, all right? So now if you notice, the R squared is 0.88, which is not very fantastic for a machine learning, a regression model, but I'm not bothered with this right now. I'm not trying to boost this with any of the boosting technologies, whether XG boost or something. That's not what I want to do right now. So all I just want to do is just to have trained this model and arrived at this figure. All right. So now that I have arrived at this, if I want to deploy this model inside of, what do you call it now? Inside of Streamlit, the first thing I want to do is to use this module called Joblib to save this whole model that I've done here, this whole work that I've done here, right? So what is Joblib? Joblib is basically a module in Python that we use to create pipelines. We just bind a group of processes together. Remember, this stuff started with imports, scikit-learn, import pandas, and all of that. Then it kept moving through steps, and at the end, we arrived at the root mean squared error. So when I invoke the Joblib module on this very whole notebook that I have here, what it does is it compresses everything into processes and saves them as one. So what I've done is this, I have created this file name, all right, lr.file, and that's the funny thing about Python. This open is both used to open an existing file, is also used to create an existing file, all right? So when you see this open here, this open is an inbuilt function. It does not mean that, it doesn't mean that this file is existing before, no. So what I just did here was to create this file, all right, using this open method, and then the file type is write and it's binary. Okay, so yeah, then I use this function called joblib.dump, this method. Now this Joblib, okay, let me just open Joblib. Joblib is not a very serious library. Joblib is not a very serious library per se. So this is how easy it is to use. It just has one, where are they? Sorry, I'm scrolling. Yeah. So Joblib just has 1, 2, 3, 4, 5, 6 methods, right? So it's either you're using this memory, parallel, dump, or load. But basically, what we use most times are these two, dump and load. We use dump to create the pipeline and compress everything together. Then we use load to invoke it anytime we're ready to use them. So that's what I did in this notebook. Basically, I just dumped the whole this model, which is this model here, all right, into this Joblib file, and then I close the file. So when I do this Joblib, you would notice that you would notice that Joblib creates that file for me. You'll see it here. So you'd see it's called LRModel. So that's what the Joblib has done. It has compressed the whole document, the whole processes, and the whole pipeline into one small document, 1 kilobyte, and it's here. So when I invoke this document, I'm going to be invoking all the methods inside, all the, like, if you look at this, you'd see there are methods like .fit, you'll see method like .predict and all of that. I can now refer to them when I invoke the document. So I'm just going to show you how it works shortly. All right. So, so I have my integrated ML app. I have my image. The next thing I'm going to do is this. So since you know that there are just 3 variables, TV, radio, and newspaper, then they give you use to predict your sales. All we need to do is we're going to create room for these 3 variables inside of our Streamlit, so that anybody that is interacting with the app can just put in an estimated amount for TV, put in a budget for radio, put in this, and then we just run the predicts and it just predicts it out for us. So let me just go straight back to this place and let's begin. So the first I'm going to do is to create an input box, all right, for TV, so that I can receive input. And if you want to receive inputs with your, if you want to receive inputs via Streamlit, use st.number inputs. You know, there's also text inputs, there's number inputs. Text input is for when you want to receive text, and the number input is for when you want to receive numbers. Again, please remember you can stop me at any time, all right? And it's absolutely okay. So I'm going to use that number input, and I'm going to say here, the label is enter your TV advert budget here. So let me just save this and let's go back to this place and run it. So you see here, I have my number input box. I can just impute any number that I like here. All right. So, you know, any number I like, all right, just imputes, and yeah, it takes it in for me and stores it to that variable called TV. So let me go and create other one for radio, and it's going to be st.number input, and I'm going to say enter your radio advert budget here. All right, then I'm going to enter one more for newspaper. So newspaper equals st.number input. Remember, they are all numbers, you know, because this is a regression problem and we'll have all numbers. Maybe next time when we look at a classification problem or something, we're going to see that we might need to receive text. So we might need to use the text input or even just drop downs, you know, for the options. So here, number inputs, and we are going to say enter your newspaper budget here. All right, so I'm going to just run this to make sure everything is fine, and so we have all our inputs. Okay, so this is where the rubber meets the road, because now we have to create this thing. Okay, so this is how Streamlit works. If you want to deploy a machine learning application on Streamlit, and basically any other place, you would need to create the whole stuff, your whole data into either a NumPy array or a pandas data frame, all right? But they're basically the same thing because a pandas data frame is built on NumPy. So I usually prefer having a pandas data frame because it just makes things very easy. So what I'm going to do right now is this. I'm going to create a dictionary because you know that various ways you can create a dictionary. You can create a dictionary from, you can create a pandas data frame. You can create it from a dictionary. So I'm going to create a dictionary right now, and I'm going to call it Imputed Dict. All right. So this Imputed Dictionary will have the following values. So the first is TV, all right? And the value that is going to have is the value of the input. Remember, this TV variable is assigned to this number input. So whatever number is imputed as TV, that's going to be the value in this dictionary. So that's the first key and the value. The second key and the value will be radio. And it's going to have whatever variable value that is captured by that variable radio here, which is this second one here. And the third one would be newspaper. All right. And this newspaper will capture whatever value in the newspaper variable. So with this, we have our dictionary. Now, if you want to create a data frame from a dictionary, so let's create a new data frame from the dictionary. We would invoke the PD. Oh no, we've not imported pandas. So let's import pandas as PD. All right, so cool. So now here we can now do PD dot data frame. Okay. And it's going to tell us that it needs something that is either a list, data frame, a dictionary. And remember, you could see that if you're invoking a dictionary, it needs you to put it in square brackets. That's what this thing is telling you so that you don't have any errors. So because I'm using a dictionary, I'm going to put a square bracket here, and I'm going to call the input dicts, all right? And so I'm just going to save that, and I'm going to rerun that here. Okay, so we're fine. There's no problem. Now, if I want to see that data frame show up here, I could actually do this. st.dataframe and inputs df. All right. So when I run this, you'll see the data frame show up here. So you can see the data frame. You can see because everything is just 0, 0, 0. It's just, if I change this to maybe 1, and I change this to 10, I change this to 50, you'll notice that they are changing accordingly. So because, yeah, that's what we instructed Python to do. So, but I really do not want this to show, so I'm just going to comment this out. But I just wanted to show you that it's possible. All right. So the next thing I want to do right now is that I am now going to invoke the model. So as usual, if I want to invoke the model, I'll have to import my Joblib. All right, so I'm not giving it any alias. So right now, I told you that we use two methods basically. We use joblib.load and joblib.dump. Joblib.dump is when we're creating the file. Joblib.load is when we're trying to invoke the pipeline, that file we have created. Remember, that file is a bunch of pipelines, a bunch of processes, right, bundled together as a pipeline. So let's call this our pre-trained model. All right. So I'm just going to say PT model, and it's equal to joblib.load. And the file name, remember, I'm just going to come back here where I dumped the stuff in my Joblib LRModel. So I'm just going to probably just copy this, and I'm going to come here, and I'm going to put that in inverted commas. Let me use this one. Okay, so LRModel. All right, it's not really that there's any difference whether it's one or two inverted commas, the one that has one or two. Okay, there's really no difference. So now I have my pre-trained model. All right, the next thing that I want to do right now is I want to put a button here such that when I have supplied all of this, I click the button to predict what's up. So that button, I'll call it a predict button. All right, so let me just create it here. Predict button. And that predict button is going to be st.button. Okay. And the first thing it's asking me for is the label. So I'm just going to call that predict. Then the next thing it's asking me for is on click. What should happen on click when the button is clicked? Now I'm going to create a new function. All right. And I'm going to call that function predictor. Predictor. So what I'm telling Python right now is that when I click this, please run the predictor for me. So now, you know the rule, when you're creating a Python function, especially if a button or another widget or something is referring to that function, you have to go immediately above it to create the function. And you can see Visual Studio is already complaining to me that there is a problem. And the problem, if you look at it, is that predictor has not been defined, right? Which is this, it's telling us that the function doesn't exist. So let's just create the function and predictor. So, sorry, def. Whenever I want to create a function, we'll start with def. So def predictor. And in this case, I'm not going to pass anything inside the function. So what do I want this function to do? I want that when I call this function, all right, I want you to load the predict function from this PT model, this pre-trained model. So remember, I told you that in this pre-trained model, you'll see the .fit, .predict, and every other methods that we used all there. So what I'm telling Python now is that I want you to go to this pre-trained model that is inside this Joblib document and bring the predict method for me. So that's basically what I'm doing right now. And what are you going to run the predict method on? Very simple, on this impute.df. Remember, when you are running your scikit-learn predict method, your predict methods will usually be a NumPy array or a data frame, a pandas data frame. So that's why I'm using a pandas data frame here. All right. So when you run that, I'm telling Python, please return M for me, because M is the value you get when you run the predict method. Okay. So that's the function predictor. And you can see right now, Python is telling us there is no more problem. So one last thing I'm going to put before our code begins to work is I'm going to tell Python that if somebody clicks the predict button, which is this, all right, if predict button, what should happen? What you should do is first create something called a result, create a variable called result. And that variable called result is a function call of the predictor function. All right, so I'm just telling you, the moment somebody clicks the predict button, I want you to invoke the predictor function and then assign the value that you get into this variable called result. All right, and then create this stuff called success is like an output, how do you call it now? Output line, all right, that just shows you what has happened. So I'm just going to say st.success prints, I'm going to use the format string. So tell me the predicted sales is, and give me what exists inside the result. Remember, this result is the value we get by running this function, all right? So let's see how this plays out in our model. All right, so I'm just going to rerun this, and now why it's taking time is because it's running the predict. You can see here it's running. So it's because it's running the predict method so that Streamlit can have it inside of its memory, so that Streamlit can cache it inside of its memory, all right? So you can see now it has finished running it. It has cached it in the memory. Next time when I rerun this, it's not going to take this long again, because unless I change something, maybe I go back to the source file, change the data set or something. But as long as the same data set that we're working on, we're good. So right now, when I click on this predict button, see what happens. It brings out the predicted sales for me. So the predicted sales is 228.70. So when we invest one in a TV advert and 1,000 in radio and 50 newspaper, this is what we get. So let's change this. Let's make this 50. Let's make this. Okay, let's even look at our data sets and try to validate how far. Remember, the accuracy of this model was about 88%, thereabout. So let's just look at how it affects this. So we're going to do the first one, TV 66.1. 66.1, and radio is 5.8, so 5.8 for radio, and then for newspaper is 24.2, so newspaper 24.2. So let's run the predicts, and it tells us that the predicted sales is 7.8 USD. Well, it's not very far from this anyway, because plus or minus because of the accuracy. But I'm sure if we implement some of those boosting stuff, the XG boost and co, and then we drop this noisy newspaper column, because this is really messing up our model. We'll drop this and then maybe do one or two other tweaks to this. The results are going to improve drastically. All right, so there you have it. Streamlit for you. All right. So I think that right now we have finished what we have for today. So we'll just take questions and then we will continue on Streamlit next week. So questions. Rahul,
I have a question.
Okay, go ahead.
Instead of Joblib, we can use other also, like model pickle file.
Yes, you can use pickle. In fact, pickle runs, Joblib runs on pickle. You get?
Joblib is different than
runs
pickle,
on
right?
pickle. Yeah, it runs on pickle. Okay, let me just show you Joblib's documentation. Just a second. I'm just trying to. I know it's captured. Aha, look at it here. So so look at this. Joblib runs basically by on pickle. So it's the same technology. You can use pickle, you can use Joblib. You can also use, what's the name of this other application? I'm trying to remember one of these other ones you could use. There are a lot of applications that create pipelines out of processes. It's one of the problems we have in Python. We are spoiled for choice. We have a lot of choice, so there are a lot you can use, but I tend to like Joblib because of its simplicity. I don't have to bug my head. I just know, hey, there are only two things you need to use: dump and upload, and we're fine.
I can do it. Yeah.
Yeah. Okay. So
yeah, I understand now. Yeah.
Right. So does any other person have a question?
For me, no.
Okay. Okay. MS, go ahead.
I'm not sure if I have to ask question because I came late. So I will try to watch the video and see if I get anything unclear, and I will ask you next week.
Absolutely. Absolutely.
Thank you very much.
All right. MS.
So I have two questions.
Great.
So number one is, will this video be on the YouTube channel?
Yes, it will be on the YouTube channel.
So far we have 3 videos and this will be added as well. Is that right?
No. That's one you have 3 videos in is the next class we're having right now. We're having that in the next 10 minutes. That's Tom's class. But this one, there's another playlist for it. So since you're subscribed to the channel, you could just look through all the videos, all the playlists that we have. You see that this one is usually in the, this one is going to be put under solving daily problems with Python. There's a playlist called solving daily challenges with Python, but I will always send you the link, the direct link to the video, and yeah.
Yeah, if you could direct me to the channel where all these sessions are there, like early morning sessions for me, early morning, that would be great.
Okay, so let me, Tom Ives mentoring. Okay, cool. So this is our YouTube channel. So if you look at the playlists, you'll see.
Okay.
Yeah, you'll see a lot of playlists here. So that one that you're looking at that has 3 videos is Machine Learning Foundations. This one, so getting into data science that we did like some weeks back before we started Machine Learning Foundations, also has 3 videos. But this is the one that we are doing currently, solving daily challenges with Python. All right. So we have Power BI, we have object-oriented programming, we have Python for data science, we have these are the playlists that are available in this, so you'll see this here because this is the series we're running now. When we run another series, we open a new playlist.
Perfect. Thank you so much.
Yeah.
And the second one is that I will be connecting Tableau dashboard to Streamlit. If you have any tips, I probably will try this weekend or early next week. If you have any tips, that would be helpful.
I'm not a Tableau person. I'm a Power BI person. So that's why you can see
Power BI. I plan to join the class tomorrow as well.
Yeah. So Power BI, for now we're on break. They said we should take a break. So we're taking a Power BI break. But we're going to start sometime later, maybe in January. We're going to resume in January. So they asked we take a break to January. But between now and the end of December, we probably are going to run 1 or 2 things on Excel, Visual Basic, and a couple of other stuff while we wait for resumption in January. So, but I would look at Tableau and possibly see, because I know a lot of people have been calling me for Tableau. So I think it's time I learn it. And then, yeah, so that I could have, the major BI tools in my arsenal. Most times they call me for training. I'm like, sorry, I don't do Tableau. I'll do the Power BI. I'm like, oh, okay. So yeah, I'm not going to lose the opportunity again. So I'm going to look at it. And whatever comes up, I'm going to let you know.
Thank you.
Yeah, you're welcome. Okay, so would there be any other questions? Would there be any other questions? All right, so if there is no other question, then can we call it a day?
Thank you so much. This was very helpful.
Thank you. Thank you. You're welcome, MS. You're welcome, Rahul. And yeah.
Thank you, Hugo.
All right, Rahul.
I will do it with my project.
Right. Okay, so we continue this next week. We should round it off next week. Probably we'll take a classification example and something a bit more complex. And then let's see how it goes. All right, so remember we're having another class, Machine Learning Foundations, in the next 9 minutes. So you can see the link on our link tree. So let me just put the link tree. Yeah, so this is integrated MLAI. So this is where we have the links to every of our activities. So if you just click on any one of them, it takes you straight to the Zoom room, right? So I'm just going to copy this address and I'm going to paste it in the chat so that you can join with it if you would love to be in that class. Today we're talking about linear algebra for